Okay, we're going to go over a few more problems from this lesson, and hopefully with just a little more explanation on a few more problems, you will feel good, feel comfortable with this lesson. It is a little bit of a doozy. Okay, number 4. And I am on page 23 of the packet. So number 4, we want to find the area of the shaded region, and the directions do say to leave the answer in terms of pi. So I'm going to do that, and then I'm also going to do a decimal approximation, just in case you ever need to know how to do that. Okay, so if I want to find the area of these shaded pieces, I'm going to find the area of the entire shape, and then I'm going to subtract the circle. Okay, well I know that this 20 is all the way across, which means that it is the diameter of the circle. So the diameter of the circle is 20, which means this diameter of the circle would also be 20. So from here down to here is also a 20. And I'm going to write my game plan down. So I'm going to find the area of the entire square, which is too much area, find the area of the circle, and subtract. So area of square minus area of circle. Okay, so how do we find area of a square? Length times width, base times height, side squared, whichever you prefer. How do we find area of a circle? Pi times radius squared. Okay, so let's do the area of the square. Length times width, 20 times 20. And then minus, now I'm going to find the area of the circle, so pi times radius squared. Well, if 20 is all the way across, that's the diameter, then the radius would be half that, so the radius would be 10. Okay, so let's work it out. So 20 times 20 makes 400, minus 10 squared is 100, so 100 pi. And that is our answer in terms of pi for the shaded region. Now, if I wanted a decimal approximation, then in the calculator, I could type in 400 minus 100 pi. Oops, I accidentally hit clear. 400 minus 100 pi, and if I rounded to the tenths, it would be 85.8. So I'm also just going to attach that in there, about 85.8. And this is area, so this would be units squared if I wanted to give it a label. Okay. Let's go to page 24, and let's look at number 7. Number 7 is the hardest one that we have that we're going to look at today. So on number 7, I want to find the area of the shaded region again. So I'm going to find the area of the whole circle, which is going to be too much shading, and then I'm going to subtract the area of the triangle, and that's going to give me what I want. So area of circle minus area of triangle. Okay, we need to figure out quite a few things. First, let's just write the formulas down. Area of a circle is pi r squared. That's no big deal. Now, area of a triangle, we have a choice. We can either do base times height divided by 2, or because this is an equilateral triangle, meaning all sides are the same length, all angles are the same measure, that makes this a regular polygon as well. So I could use 1/2 AP if I wanted to, or base times height divided by 2. I'm going to go ahead and do the 1/2 AP just because that's fairly new to us and it'll give us a chance to practice it a little bit more. But you could definitely do base times height divided by 2 because it is a triangle. Okay, I do not know the radius of the circle because the radius goes from the center all the way to an edge, so that 2 square root of 3 there is not the radius of the circle. So I'm going to start working with my triangle and see what I can figure out with that. Okay, this guy right here, that 2 square root of 3, that is the apothem. So I already know it. I'm going to go ahead and just put it in. The apothem is 2 square root of 3. I just need to work on finding the perimeter. Remember the distance from the center of the circle to a middle of a side, that's the apothem. Okay, if I want to know about all my central angles, because this triangle has 3 sides, it's going to have 3 central angles. So to know what each central angle is, I take 360 and I divide by the number of sides, or the number of central angles. And that makes 120 degrees. Okay, so that means if I were to draw them in, that all these central angles would be 120. This is 120, this is 120, this whole angle right here is 120. Well, what the apothem does is it splits that 120 in half. So this is going to be a 60-degree angle. Okay, I am going to blow this triangle up right here off to the side, just to make it a little bit bigger to work with. Okay, so the 2 square root of 3 is the apothem. That's this piece right here. We just talked about how this whole central angle is 120, so this is half of that, 60. This is the 90, of course, so this would be the 30. Okay, let's do our labels. Across from the 30 is our x, so I'm going to put an equals x. Across from the 60 is x square root of 3, and across from the 90 is 2x. Okay, we actually know what x is. X is 2 square root of 3. So let's start with this one. This means we're going to take 2 times x, which is 2 square root of 3. And how much is that? 4 square root of 3. Okay, and then this one wants you to take x and multiply it with the square root of 3. Okay, so x is 2 square root of 3. I just replace that into the x, and then I'm going to recopy the square root of 3 behind it. Well, what's square root of 3 times square root of 3? Square root of 9. And what's the square root of 9? 3. So what's 2 times 3? 6. Okay, so from here to here, that's the 6. And from here to here, that's the 4 square root of 3. Okay, so let's talk about what all this means. We know a lot of stuff now. If from here to here is 6, what is it from here to here? 6, which means the whole side of this triangle is 12, which means this whole side is 12, which means this whole side is 12. So when I go to find the perimeter of the triangle, it's 12 plus 12 plus 12, which is 36. Okay, we also found something else very important. The radius of the circle should go from a center to an edge of the circle. So this is the radius, this is the radius, because it goes from the center to an edge of a circle. And what do we find that to be? 4 square root of 3. So pi times 4 square root of 3 squared. Okay, I am going to do this first, keeping it in simplest radical form and in terms of pi, and then I'll give you a decimal approximation. The first thing I need to work out is this guy right here. So this means 4 square root of 3 times 4 square root of 3. I'm going to just come up here for a second and do it up here. So 4 square root of 3 times 4 square root of 3. That's what it means to square it. So first I'm going to multiply the outside numbers. 4 times 4 is 16. And then I'm going to multiply the square roots. What's square root of 3 times square root of 3? Square root of 9, which is 3. And then what's 16 times 3? 48. Okay, so coming back down here, this squared gave me 48, so I have 48 pi. Okay, when I do this problem, I'm going to ignore that square root of 3 and just work it out. So I know a lot of you would take 36 times 2 and divide by 2, so I'm going to do it that way real quick, and then I'm going to talk about another way. 36 times 2 divided by 2, which is 36. Another way I could do it is half of 2 is 1, and 1 times 36 is 36. Either way, I get 36. So minus 36, and then I reattach the square root of 3. And that is our answer. Oh, I lost the pi. I'm so sorry. This made 48, and 48 times pi is 48 pi. So this is 48 pi minus 36 square root of 3. There it is in simplest radical form as well as in terms of pi. Now, if I want a decimal approximation, I'm going to put 48 pi minus 36 square root of 3 in my calculator. And if I round to the tenths, I would say 88.4. So, or approximately 88.4. And this is area, so it would be units squared, because I don't have a unit that I'm specifically working with. Okay, he was a doozy. Let's go to 8. It's kind of hard to tell what is shaded here, but it wants us to find the unshaded region in terms of x. So what is shaded, I believe, is this guy right here. I can't really tell on my paper. So we'll just go with it. We'll say that this is the shaded piece. Okay, so it says the shaded area is 200 square inches. So this area right here is 200. And we want to represent the unshaded region in terms of x. So if I want this unshaded region here, then I can take the whole rectangle, which is too much, and subtract the shaded piece, and that'll give me the unshaded piece. So that is my game plan. I am going to take the whole shape, the area of it, and I'm going to subtract the area of the shaded piece, simply because I want the unshaded piece. Okay, so let's start off. The area of the whole thing is a rectangle, so I'm going to take length times width minus the area of the shaded. Well, we already know the area of the shaded. The area of the shaded is 200. Okay, now let's look at our rectangle. The length is 10, the width is x, so this would be 10 times x, or 10x, minus 200. And there it is. That's our unshaded region in terms of x. He was easy peasy. Let's give him a smiley face. Okay, number 9. This one, our triangle, is shaded. And we are trying to find the area of the shaded piece. So a minute ago I did a triangle and I did it 1/2 AP. This time I'm going to find the area of the triangle using base times height divided by 2. And I don't need to subtract anything. If I just want to know the area of this shaded piece, I can just find the area of the triangle and I'll have my answer. I don't have to find the area of the whole thing and subtract this, because that would give me this guy here and this guy here. I'm just going to find the area of this triangle because he's the one that's shaded. Okay, so that's what I'm doing. I'm finding the area of a triangle. This time I'm going to use base times height divided by 2. And what is the base of our triangle? 1/2 x. Okay, then the height of the triangle. Since this shape is a square, if this side is a 1/2 x, what is this side? A 1/2 x. So what's the height of the triangle? 1/2 x. And then I'm going to divide that by 2. Okay, some of you are a little bit better with your fractions than others, but if I want to take 1/2 times 1/2, I multiply straight across, straight across. So 1 times 1 is 1, 2 times 2 is 4, so this makes 1/4 x squared. So 1/4 x squared, and then I'm dividing that by 2. So dividing that by 2. And if you want to take 1/4 divided by 2, some of you probably already know the answer. I'm going to show you with the calculator. 1/4 divided by 2. Math inner makes 1/8. And the area is 1/8 x squared. And that's it. Okay, just a little more practice with this lesson. Hopefully that helped. Thank you.